Hey all, welcome to Komli Mom online classes. Happy morning, all of you. Happy morning, happy morning. Hello, hello. Say happy morning. Everybody, come on. Happy morning, happy morning. I can't see many of your cameras are off. Please check your cameras. Please check your cameras. Hello, hello. 100% attendance I need. 100%. Please on your cameras. Everybody, come on. Wish your teacher. Put message in your chat box. Say happy morning. Come on, say happy morning, happy morning, happy morning. Come on, faster, faster. I need happy morning. I need happy morning. Hello, hello. Come on, happy morning, happy morning, happy morning, happy morning. Come on, happy morning. Very good, very good, very good. Super. Happy morning, happy morning, happy morning. Very good, very good. Come on, still. Still cameras are off. Please check it out. Check your cameras. Still Pratibha. And see, you have to keep your name according to your student ID. I don't want to see any single names like Varshini, for example. Where is your student ID? Pratibha Benival, no student ID. Anil Kumar, Ramya, Del, Janavi, Subhashini, come on, change your IDs in Zoom settings itself so that no need to change every day. Okay? I will call your names also personally and I'll talk to you. If your name is not correct, I cannot talk to you. Maybe your father name, mother name, if you keep, I cannot. Even Rahul. Hi, Rahul. How are you? Huh? Keep your names, change your profile pictures. You can put your own profile picture, Rahul, on your video. Okay, coming to in this batch, what you are going to learn, everybody? Complete class 12th chemistry, correct? What is the duration of the course? 3 month. Today is from today date to 3 month your course is going to start. Till now what you have attended your foundation classes, which I provided you for free, correct? And now come in this 3 months, what you are going to learn? First 1 month is physical chemistry, next 1 month organic chemistry, next 1 month inorganic chemistry. Three parts of chemistry clearly segregated, one month each. Is it possible to finish entire syllabus? It is possible. It is, you will finish it very easily. What support I need from you is, you should not miss the class. This is the only thing you can do. What do you have to do? Sharp time you should sit in the class. Okay, ready? Shall we begin today's session? What are the three chapters you are going to learn under physical chemistry? Chapter number 1, solutions. Chapter number 2, electrochemistry. Chapter number 3, chemical kinetics. If you are perfect in these three chapters, your physical chemistry is done. Okay, repeat the name of the chapters, everybody. What is the first chapter? Solutions. What is the second chapter? Electrochemistry. What is the third chapter? Chemical kinetics. Very good. See, I teach you from basic level, from zero level onwards. I teach you. In few of you may have certain knowledge already if you are a repeater, but I consider you as an like a 10th class, 9th class student. If it is there in a class, they don't know anything. So I should start from that level. I put that point in my mind and I teach you. Okay, so if any of you have certain knowledge, please bear me some time until all students comes to equal level, then we go depth of the syllabus. Okay, everybody clear? Each topic from basic I'll start. So it is not like today basics, tomorrow depth. No, every day that particular topic, it starts from basics. Okay, everybody listening. And practicing also most important. Today what you are listening, you have to practice evening. or evening who are listening, you have to practice morning. Like that you should plan your practice session, like depends on your capability. Few of you may need 30 minutes practice, few of you may need 40 minutes, few of you may need 10 minutes practice, but practice is must. Ready now everybody? What is the name of the chapter you are going to learn today? Solutions. Actually, I'm waiting for this day. When this day starts, I am waiting to see you all. Remove all the fear from your heart. Remove it. Remove it. Any fear, any tension is there in your heart, remove it. Komali ma'am is with you. You are going to rock chemistry. It's my responsibility. Okay, na? If you face any difficulty, when I'm teaching, na, some of you, any of you may, if not clear any point, circle it with a pencil. Okay, when I'm teaching, if you interrupt in between, I may not, it may be the disturbance to the other students. So what you do is, if any point is not clear, just to circle it. If you feel that if any point I wrote mistake over the screen, then you can raise your hand, ma'am, this is some correction by mistake you have written. You can immediately you can inform me. Okay, so that mistakes won't be entered in your running notes. But if you feel like, ma'am, this point is not clear for me, it is very much troubling, you raise your hand. If it is a minute thing only, means you just wait. At the end of the class, you raise your hand. I will clear your doubts, then only I'll end the session. Okay, everybody, all the instructions are clear. Your camera should be on. You should not talk to your parents when class is going on. Your siblings, no distractions. Eating not allowed. Drinking water, drinking any juice, you can do that. Okay, focus is most important. You and Komale ma'am, we two only should be there in the class. Ready na? Ready? Put in chat box. Ready, ma'am. Ready, ma'am. Come on. Ready, ma'am. Ready, 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 ready. Ready, ma'am. Ready, ma'am. Ready, ma'am. Very good. Very good. Very good. More activeness I want. Remove the fear. Remove it. Even you are zero today, remove the fear. Why fear? When Komali ma'am is here. Remove the fear. Come on, remove it, remove it. Very good, very good, very good. Start interacting with me. If you are interacting with me, you get more energy. Okay. Start interacting. Very good. I see each and every of you, like very less number of students, very less. I can easily see everyone here. Very good. Super. What is the name of the chapter? Solutions. Easy chapter. Very easy. After learning, you say, ma'am, that's it now, you say. Come on. Very good. Very good. Easy chapter. Can you see the screen? Yes. Put the heading. True solution. I dictate the notes every day. Every point I give you the notes. What is your responsibility is neat handwriting. Every side heading. Every point which comes on the screen. Additional points, what I am discussing. Everything you should put in your running notes. And you have to share good handwriting notes. Again, I'll collect from you and I share to everyone. So please write with good handwriting. Come on, write point number 1. What is the meaning of true solution? Before going to start this chapter, you should understand what is true solution. It is homogeneous mixture of, come on, write everybody. It is homogeneous mixture of two or more components. What is the meaning of this homogeneous? Homogeneous. Homogeneous mixture of two or more components. These two are the two different terms you should understand. See, components meaning is substances. Like sugar is one substance. Sugar is one substance. Salt is one substance. Same way, H2SO4 is one substance. NaOH is one substance. So, it is components meaning is substances. It is a homogeneous. What do you mean by homogeneous? Homogeneous means if you mix these two substances, there is a uniformity, which means that they mix completely. Like for example, take 1 spoon of sugar, mix in a glass of water, put in a glass of water. What you are doing? Take 1 glass of water, take 1 spoon of sugar and mix it. It will dissolve or not? Tell me students, it will dissolve or not? Put in chat box, dissolve or not? Yes or no? Yes means Y, no means N. Yes or no? Yes, it will dissolve. Very good. It will dissolve. So if it dissolves, after dissolving, will you able to separate them? Like by seeing, can you distinguish them? Ma'am, this is salt, this is water. No, they mix completely. If you see, same uniformity will be there. If two components mix uniformly, then those solutions are called as homogeneous solutions. So what are true solutions? True solutions are homogeneous solutions which mix uniformly. That's why we call it as homogeneous. And that type of solution is called as which solution? True solution. What do you mean by heterogeneous? Heterogeneous means if you are mixing two different substances, they don't have that uniformity. They form a type of solutions called as colloidal solutions. If the substances are not mixing uniformly, we call them as heterogeneous solutions. But heterogeneous solutions you don't have in syllabus, which is removed. Surface chemistry one chapter used to be there earlier, like to up to 2023. That surface chemistry chapter is removed. So you no need to study about this heterogeneous mixtures. Clear? Clear? Copied? Come on. Faster you have to copy. Clearly, neatly, faster you have to copy. Hmm? Very good. Very good. Come on. Finished? Finished? Good handwriting. Faster. Focused. You should be in the class. Very good. Super. Moving to the next page. Going. If any time now you are not able to write it or any next page I'm moving, just to take one screenshot by that time. Later after a class also you can copy that slide. Now, okay, ma'am, I understand true solution. Give me some examples. Let's say, for example, I take 1 glass of water. In that 1 spoon of glucose I put. Homogeneous or not? Homogeneous. Take 1 glass of water. You write like this H2O down, right hand side down, subscript like this you should write. Next to that you should not write. Little down. That liquid sign is a state. It represents state of the substance. L stands for liquid. S stands for solid. Now take a 1 glass of water. Put 1 spoon of sugar. See sugar na. Sugar is a solid. So down I am writing S like this. Solid. That represents the state of the substance. If I take 1 glass of water, in that 2 spoons of alcohol I added. So all these mix uniformly. When we add these two substances, they mix uniformly. That substance is called as which substance? Can you tell me? Homogeneous substances or homogeneous mixtures. Copying. Come on, faster. Moving. Homogeneous, homogeneous, homogeneous. Homogeneous means same, same, uniform. Uniformly mixing, uniformly mixing. Very good. Moving, moving, I'm moving. Very good. Copying still, copying still. Next. Solutions is made up of any solution made up of two components or more than two components. Anything like I want to prepare lemon water. What I do? I squeeze half a lemon. I put 1 spoon of sugar, 1 glass of water. So in that, how many components are present? Water is present, sugar is present, and lemon is present. 3 components. So solution can have 2 components or more than 2 components. So solution is made up of 2 or more than 2 components. Mainly we study binary solutions. What do you mean by binary solutions? Solutions which are having 2 components. So what are those 2 components? One is a solute, another one is a solvent. Repeat everybody. What is that? One is a solute, another one is a solvent. Come on, write fatafat. What is that? Solute, solvent. Solute, solvent. Repeat means you should read, like how 5th class children will read in a class. Same way you should read. Solute, solvent, solute. So lip movement, I see from your lip movement. Lip movement is not there. Imposition I'll give. Okay, what you should do? Solute, solvent, solute, solvent. See how many times I'm repeating? It will sit in your mind. If you repeat, it will sit in your mind. Okay, solute, solvent. Very good, very good. Okay, ma'am, understand. Solutions have 2 things. One is solute, another one is solvent. Okay, what is the solute? What is the solvent? Let's see that. There are 2 rules. Okay, second rule is very common rule which you usually we see everywhere. Rule number 1, little you have to focus. There are 2 rules. Repeat, how many rules are there? 2 rules, 2 rules. Rule number 1, rule number 2. Now let us see what is this rule number 1. For example, solid I am mixing in a liquid, I am getting some liquid solution. For example, the solid is like sugar. What is a solid, children? Tell me. Sugar. What is the liquid? Liquid is like glass of water. Water is present in 1 glass. Now, sugar, if I put in water, 1 spoon of sugar in a glass of water, tell me that solution I get is liquid or solid or what? Gas. What I get? Before that, tell me, what do you mean by matter? Class 9th you study matter, right? What do you mean by matter? Anything which has some mass and occupies some space. Like this pen. This pen has some mass. What do you mean by mass? Some weight. Some weight. It has some weight and it's occupying this space. So it is a matter. Matter, any substance we consider as matter. Matter is classified into 3 things, which in a simple way to say. What are those 3? Solids, liquids and gases. Solids, liquids and gases. What do you mean by solid? Solid, let's say for example, this pen is a solid. Okay, duster is a solid. Chalk piece is a solid. Correct? What do you mean by liquid? Water is a liquid. Alcohol is a liquid. Petrol is a liquid. Kerosene oil is a liquid. Normal cooking oil is a liquid. Are you getting my point? It's a liquids. What do you mean by gases? Like gases, air is a mixture of gases. Oxygen is a gas. Nitrogen is a gas. So, solids we write with S. Liquid we write with L. Gases we write with a G. Solids, liquids, gases. Okay, this is a basic information. Very basic information. Fine. Now here one rule I want to convey. Just listen this rule. Solvent is in same phase as solution. That is the rule. What is the rule? Read the rule everybody. Come on children, read the rule. Solvent is in same phase as solution. Solvent is in same phase as solution, which means that solution, if it is in liquid, solvent also liquid. Solution is a solid, solvent also solid. So how can you identify? For example, what I'm doing is solid plus liquid. I'm mixing, I'm getting liquid. So this is a liquid, this is a solution we are getting, right? Solution we are getting, right? Now in this two, which is a solvent, can you say? Which is a solvent? This liquid is a solution means solvent also liquid only. Solvent also liquid only. What is the rule? Solution and solvent both should be in same phase. Both should be in the same phase. For example, I am getting, for example, simple example just to make you understand, solid plus liquid I'm mixing. I am getting solid only, which means that solid is more actually. In that little water I added. So I am getting only solid only. Okay. So now can you tell me which is our solvent? See, this is our solution. This is our solution. Solution. What is the rule? Solution and solvent both should be in the same phase. So which is our same phase? This is our solvent. This is our solvent. So both should be in the same phase. Both should be in same phase. Okay. This rule is not that much required. Just for an idea I have discussed with you all. Okay. Very good. For example, what I'm doing is I'm taking a spoon of glucose and I'm mixing in a glass of water and I'm getting a liquid solution. Can you tell me what is my solvent now? Glucose now, water now. Huh? Come on. Glucose now, water now. Which is the solvent now? Put in chat box glucose or water. Glucose or water. Come on, faster. Glucose or water. Super, super. Very good, very good. Water is our solvent. Very good. Water is our solvent. Because liquid is a solution is in liquid state. So solvent also should be in a liquid state. This is rule number 1. Now, let us see rule number 2. For example, if both are liquid solely, then how can we identify? In a previous case, you're listening, right? You're listening, right? See, previous case, one is a solid, one is a liquid. So we all identified that. But now, one is both are liquid solely. How can we identify? In such cases, the rule is the substance which is more in quantity is called as copied. Copied? Right. The substance which is more in quantity, we call it as solvent. The substance which is less in quantity is called as a solute. Repeat, what is a solute? The substance which is less in quantity is called as solute. The substance which is more in quantity, larger in quantity, we call it as solvent. Solute plus solvent together we call it as solution. Okay, understand. Now, let us see one example. You tell me, I am taking 1 mole of water. What is just 1 mole? What do you mean by this word mole? What do you mean by this word mole? See, we say, Bhaiya, give 1 kg apple. See, we are telling give 1 kg. Bhaiya, I need 1 liter milk. Please give 1 liter milk packet. So 1 liter. Here kg, liter. Oh, your temperature is very hot. So temperature is above 35 degrees Celsius. So we are telling temperature 35 degrees. That units are there, no Celsius, this liter, this kg. These are the units to measure the substance. But in chemistry, we cannot say in kgs because atom's weight is very, very small. That time, the term which we use is mole. Again, one specific chapter only there in class 11 chemistry. That time full we learn about this mole only. Until that, just what do you mean by mole is? It is a unit. Remember that. It's just a unit to measure the weight of a substance. H2O, how many moles? 1 mole. Alcohol, how many moles? 9 moles. Out of these two, can you tell me which is larger in quantity? Which is larger in quantity? 1 na, 9 na? 9. So 9 mole is more in amount, so it is a solvent. Very good. Now, put in a chat box. Here water is 9 mole and alcohol is 1 mole. Which is a solvent? Water or alcohol? Water or alcohol? Don't worry if you don't know, ma'am, this is alcohol or what. OH functional group is there means alcohol. No problem. Again, in organic chemistry, you learn everything. So C2H5OH is alcohol formula. Okay, na? Now 9 mole, 1 mole. Put in chat box which is in solvent. Water or alcohol? Water, water. Very good. But here it is given like this, no? Now it is correct. Arrow should start from here. Water is 9 moles. So more in amount and that is a solvent. Very good. Two rules are very clear. Basic rules, very easy rules. What is that? One is a more in amount, one is smaller in amount. Smaller in amount is solute, more in amount is solvent. So, which substance is more? Solvent is more. So, I will say first, 1 for solvent. So, whenever I am writing moles for solvent, I'll use number 1. Okay? Anywhere if I am using N1, I am writing. What is the meaning? You have to tell me. Number of moles of solvent. Okay? 1 if I am writing. For example, M1 I am writing means molar mass of solvent. 1 I always use entire chapter, same thing I use. So, sometimes if I don't like to use 1 means I will use A. What I use? A. Capital A. This is also indication of number of moles of solvent. If I use MA, what is the meaning of MA? Molar mass of solvent. Repeat, read. Molar mass of solvent. Okay? Now, which amount is smaller in quantity? Which is a smaller in quantity? What do we say? Solute, we say. Solute, solute. For solute, I use the term 2. Okay? And for number of moles of solute. Molar mass of solute, what I use? Tell me. Molar mass of solute, M2. Very good. Sometimes, if I don't like to use 2, alternative is B also I'll use. Both are same. Some textbooks if you refer or any material or something if you see, sometimes they write 2, sometimes they write B, no problem. Both are same. Okay? Is it clear for you? Very good. Very good. And one formula I want to say, this formula put in your mind. Number of moles is there, no? Number of moles. It has one formula. There are many formulas. Just we will see one formula which we use more frequently in this chapter. That is weight by molecular weight. Tell me what is the formula? Weight by molecular weight. Repeat everybody. What is the number of moles formula? Weight by molecular weight. Repeat again. Weight by molecular weight. Let's say for example, some molecules I'll give you. H2SO4 molecular weight is how much? Like 98. 98. Remember this. Until you learn mole concept, few molecules you just remember if you don't know how to calculate. In foundation classes also I kept in schedule. Sir discussed I think with you all. Okay, if any of you missed also, watch that recorded session which I have shared you. Okay, H2SO4 molar mass is 98. Again I will discuss when the chapter comes. H2SO4. Let's say for example, how we get this molar mass? For example, water is there. How to get a molar mass of water? Hydrogen atomic weight is 1. So atomic weights, day 1 of foundation class you should go through. If any of you missed. Hydrogen atomic weight is 1. Another hydrogen atomic weight is 1. Oxygen atomic weight is 16. So sum of all atomic weights if you add, you will get 18. Let's say unit gram. Don't worry, we will discuss later about the units. 18 gram. Okay na? So any substance like this you have to. For example, NaOH. Sodium, how much is the atomic weight? 23. Oxygen 6. 16. Hydrogen 1. Total, if you add sodium, oxygen, hydrogen, total it is 40. In such a way we calculate. So to calculate like this, the basic information which you need is reading of atomic weights from 1 to 30. If you know this 1 to 30 weights in your mind, easily you can add it. Understand? Everybody clear? Okay, fine. Now, I'm going to discuss the next concept called concentration terms and interconversions. Concentration terms and interconversions. What do you mean by concentration terms? Very easy. See, sometimes, for example, tell me, I have one glass of water. I kept 1 spoon of sugar. Fine. I have another glass of water. I kept 10 spoons of sugar. In first glass, one spoon of sugar. In second glass, 10 spoons of sugar. Which is more sweeter in taste? First glass or second glass? First glass, come on, I need answer. First glass or second glass? Second glass. More sweeter in taste. Your brain is, you see, you should sit very freely, like free of mind, distraction free mind. No thought should enter in your mind. Only you and Komali ma'am. Every point, like, fifth class boy, how he involved in a class. He forget everything. Simply he listen, he enjoy. In the same way, you have to enjoy your learning. You have to enjoy this process of learning. You should not feel like a burden. I'm attending chemistry class. Listening, simply laugh, simply answer to the question. Solute ma'am, solvent ma'am, solute ma'am, solvent. Every point you should pay attention. Listening, very good. See, one glass, what I told, one glass, 1 spoon of sugar. Another glass, 10 spoons of sugar. Which is sweeter in taste? 10 spoons, one is sweeter in taste. So if I ask you a question now, which is less concentrated? First glass. Which is more concentrated? Second glass. So now, what do you mean by concentration? It is with respect to amount of solute which is present in a given solvent. So based on the term concentration, you are going to learn now different concentration terms. Why? If I give this 2 glasses, you drink and say, ma'am, this is less sweeter in taste. This is more sweeter in taste. We can drink that and we can say. But if I give instead of 1 spoon of glucose, I'll put 1 spoon of H2SO4 in 1 glass of water. Another glass of water, 10 spoons of H2SO4 I'll put. Come on now, please taste this H2SO4 solution. Can we? No, we cannot taste the chemical compounds, chemical substances. So, concentration we cannot find through tasting. Concentration we have to find through some chemical terms like molarity, normality, weight by weight percentage, weight by volume percentage, ppm. Like this, there are some concentration terms. Now, you all are going to learn these concentration terms. Everybody clear? Sorry. Clear? Very good. Very easy. Very, very easy. Just see how easily you can learn. Put the heading. First concentration term. Mole fraction. Come on. Faster. I need faster writing. You have to save the time while writing. Little faster but good handwriting. Good handwriting. Mole fraction, and purchase this highlighters also 20-25 rupees. If you put highlighter, radium color, one highlighter, orange, blue color, okay, purchase this highlighters. Side headings you should highlight. Red, blue, black pens always should be there in your pouch. Your chemistry pouch and chemistry book separate. You should not use for other subjects. My subject separate pouch. Morning it should be ready. You should not search anywhere. Come on. Mole fraction. What do you mean by mole fraction? Number of moles of component by total moles of the solution. What is this? Let's see. Mole fraction is denoted by X. Simply Xi we say, but simply. xv, right? X, no need to show this symbol like this. Simply you write x, no problem. What I'm telling, for example, I have this solution. Listen carefully, everybody. I have the solution, one container, one beaker I have. In this, there is a substance A, this is a substance B, two components. How many components I have in this container? There are two components. First component A, I will write it as Na. What I write? Tell me. Na. Second component I'll write, tell me what? NB. Very good. NaNB. Super. Now, how to write mole fraction with respect to A is XA. I'll write XA. Why XA I'm writing? I'm going to write with respect to A. If I write with respect to B, XB. Okay. With respect to A I'm writing. So first in a numerator I should write Na. And denominator I should write total moles. How many? Na plus Nb. Na plus Nb. Repeat the mole fraction of A formula. Mole fraction of A is Na by Na plus Nb is the formula. Can you tell me mole fraction of B formula now? With respect to B, you should write Nb divided by total again. Na plus Nb. Everybody clear? If suppose in the same container, if I have C also means, then XC is equal to Na by Na plus Nb plus Nc. All the components you should take in denominator. What do you mean by numerator? Top one is a numerator, N. Down one is a denominator. Clear? Numerator, denominator. Numerator, top is numerator, we say. Down is denominator, we say. Okay. Now, total mole fraction. Can you say what is the total mole fraction? XA. Solvent. I told you A I will use for solvent. XB I use for solute. Solvent plus solute is equal to solution usually. Now, we are mixed. My speed is okay? I'm not going so much fast, right? Okay, no? XA plus XB. You are mixing both. If you are mixing both, tell me what can be the formula? Na by Na plus Nb plus, this is what? Nb by Na plus Nb. So, two substances mole fractions you are adding. So, whenever you are adding like this, just observe this denominator is same. When denominators are same, you can add it directly. See, I am taking LCM. Na plus Nb is a common. So, Na plus C 1 by 2 plus 1 by 2 is there. 1 by 2 plus 1 by 2. So 2 is there in common. No, just you can take 2 LCM. You can add directly this to 1 plus 1 you can add. Okay, same way what I do is bases are same. If bases are same, you can, if denominators are same, you can add a numerators. So Na plus Nb. Then we'll get the formula. Na plus Nb, Na plus Nb will be cancelled. Then you get 1. So this simply I am discussing with you. You no need to practice so much this derivation. Remember, XA plus XB is equal to, what is the formula, children? Tell me. XA plus XB is equal to 1. Say what is the formula? XA plus XB is equal to 1. See this presentation again, it won't be shared to you. You should write it. That's why I'm discussing. I'm giving notes. Your own handwriting. Notes verification also will be there. One session I'll give it a coordinator. They'll come and check your cross verify your running notes. Chemistry, physics, biology should not put all in one notes. Separate. Chemistry only for chemistry running notes. Okay, na? You don't do like that, but instruction I'm giving you. Mole fraction. Okay. Tell me what is the formula of mole fraction? Mole fraction is denoted by xi. XA plus XB is equal to 1. X is equal to Na by Na plus Nb. Very good. Now, see the next one. See the next one, next formula. Molarity. Put the heading. Molarity. Little faster. Molarity. What do you mean by molarity? The number of moles of solute that is dissolved in number of moles of solute dissolved in 1 liter of the solution. If you want to write the definition, you can write. Otherwise, this is enough. The number of moles of solute dissolved in 1 liter of solution. Okay. Now, one question I'll ask you. Tell me. 3 molar. What is the meaning of 3 molar? If you see anywhere 3 molar means 3 moles of solute in 1 liter. What is the meaning of 3 molar? 3 moles of solute in 1 liter. So better you write here. One formula you write. Number of moles of solute. Right here. Here you write. Number of. Like this you write. Number of. NO dot means number. Number of moles of solute. Solute. S-O-L-U-T. Solute. Dissolved in 1 liter. Dissolved in 1 liter of solution. 1 liter of solution. Number of moles of solute dissolved in 1 liter of solution. Okay? 1 liter fixed. 1 liter fixed. If I say 3 molar, can you tell me what is the meaning? 3 moles of solute in 1 liter of solution. 1 liter of solution. If I say 5 molar, what is the meaning? It's most important. 5 molar. What is the meaning of 5 molar? Repeat everybody. Write full form of 5 molar. Write full form of 5 molar. 5 moles of soluting. We are entering. Each concept step by step we are entering. 5 molar means 5 moles of solute in 1 liter of solution. Very good. Next. 2 molar also you write. 2 molar. What is the meaning of 2m? If any question you have seen 2m, immediately you should write there. Okay, Komli ma'am told 2m means 2 moles of solute dissolved in 1 liter of solution. So by seeing this, you got 2 basic informations that 2 means solute weight 2 moles and solution is 1 liter. Based on this, we will find another question. Okay? This idea is 1 molar means, can you say, write full form of 1 molar? Come on, practice. 1 molar, 1 molar. Come on, 1 molar. 1 molar. Put in chat box, 1 molar meaning is how many moles of solute? 1 molar means how many moles of solute? Very good. Very good. Come on, super, super. 1 mole of solute means, 1 molar means 1 mole of solute in 1 liter of solution. Solution, denominator is what? Solution. Don't confuse with a solvent. No, solution. Molarity, denominator is solution. Very good. Now, here one thing I'll tell you. Molarity is what you learnt. Molarity, capital M. What is the symbol? Capital M. Number of moles of solute, N, divided by weight, volume of solution. So, solution I will write SOL. Ma'am, solvent also SOL? No. No, for solvent I'll use 1. For solute I will use 2. Okay? For solution I will use SOL. SOL, shortcut, always. So, you can write here 1 I always use for solvent. 2 ma'am always use for solute. And SOL ma'am always use for solution. This is a fixed things. Very good. So, number of moles of solute dissolved in a certain volume of the solution, like 1 liter volume of the solution. Very good. Now, I gave you one formula for moles. What is the formula? N stands for what? Moles. V stands for volume. V stands for volume of solution. Okay, fine. N formula I told you. What is N formula? Weight by molecular weight. Weight by molecular weight. Capital M stands for molar mass or molecular weight. Both are same. Both are same. Clear difference we will see in mole concept chapter. Don't worry now. Molar, sometimes I use the word molar mass. Sometimes I use the word molecular weight. There is a slight difference, but no need in this solutions chapter. You no need to focus on that. Okay, fine. Now, what I do is N2 place na. Instead of writing N2, I'll write W by M. What do you mean by W? Weight of solute. Solute 2. Molar mass of solute. So I'll write W2 by M2 into. This is in denominator, right? So 1 by V na. So I'll write separate 1 by V of solution. So repeat molarity formula, everybody. Molarity is equal to N by V or W2 by M2 into 1 by V of solution, volume of solution in a liter. For example, if you are taking volume in a milliliter, then what we have to do is, for example, solution volume is in milliliter. Then milliliter, how can we convert into liter? By dividing with 1,000. So milliliter, if you divide with 1,000, we get a liters. Then same formula, I am going to write W2 by M2 into 1,000 by volume of solution in a milliliter. This is one formula. So this is a molarity one formula. So see now how many formulas? Either sometimes I will use this formula. Sometimes I will use this formula. Sometimes I will use this formula. There are three formulas I use for molarity depending upon the question. Repeat the three formulas. Molarity is equal to N2 by V or W2 by M2 into 1 by V in liters or M is equal to W2 by M2 into 1000 by V in a milliliter. Three formulas. Everybody clear? Very good. Very good. Now, put the next heading, molality. 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 Same thing. Oh, here, molality, no, molality, small m you should write. Small m. Small m. It is denoted by small m. That is capital M, this is a small m. Write the formula of molality. Number of moles of solute dissolved in 1 kg weight of the solvent. What is the molality, children? Tell me. Number of read and writing, reading, writing, reading, writing. Because now when you are reading, no, your mind focus, brain focus on that particular part. Otherwise, your thoughts will be deviated out of class. You will go. So molality, molality, number of moles of solute by weight of solvent. Like that, reading, writing, reading, writing. Very good, very good. Come on. So what is the difference between molarity and molality? Denominator difference. Denominator means down part. See, D. Denominator down. Denominator down. Okay. So there what is there in molarity? Volume of solution is there. Here what is there? Weight of solvent is present here. In a kg. In kg. Now, my question is, if I say, here you write the definition. Here you write number of moles of solute. Right? One line you write. Number of moles of solute. Number of moles of solute dissolved in 1 kg of the solvent. Number of moles of solute dissolved in 1 kg of the solvent. 1 kg of the solvent. Okay, fine. Now, if I use the term 3 small m, what is the meaning? Write it. Right there. How many moles? How many moles? 3 small m means how many moles? 3 moles. 3 moles of what? Solute. 3 moles of solute. And dissolved in how much? 1 kg of the solvent. Very good. Write that. 3 moles of solute. 3 moles of solute dissolved in 1 kg of the solvent. 1 kg of the solvent. If I say 2.5 moles, 2.5 molal. What is the meaning of 2.5 molal? Can you tell me? 2.5 molal. Put in chat box how many moles of solute in 2.5 molal. How many moles of solute? Come on, faster. How many moles of solute in 2.5 molal? Very good. Very good. 2.5 moles of solute. How much weight of solvent? Weight. I'm not using volume. In a molality, we use denominator weight. Weight of solvent. That is the most important. In a molarity, solution volume. That is volume of solution. This is weight of solvent. These are the two different, completely different concentration terms. Very good. Now, same way, how we wrote for molality, now we will write formulas for molality. Very easy. See how I am writing. Molality is equal to number of moles by weight. I told you that number of moles of solute, I will use term 2. 2 number. For solvent, I'll use number 1. Okay, now? And it should be in a kg. So, kg, I'll write here. N2 by W1 in kg is very good. Now, N2 full form, how can we write? Elaborated form, how can we write N2? W2 by M2 into, I will separate this 1 by W1 kg. Okay, this is one more formula. And another formula. If any time, if we have in grams, so weight if it is in grams, solvent weight in grams, then this formula is not correct. Always we should convert grams into kg. How to convert grams into kg? Just divided by 1000 if you do, we can convert this grams into kg. That 1000 is denominator, so it will go to the numerator. Then it will be W2 by M2 into 1000 by W1 in grams is the formula. So total how many formulas you have studied for this molality? Can you tell me? First formula is N2 by W1 in kg. Second formula is W2 by M2 into 1 by W1 kg. What is the third formula? W2 by M2 into 1000 by W1 in grams. There are 3 formulas for the molality. Okay. What do you have to do? You have to practice today all these formulas again you have to practice. Then it will fix in your mind if you practice. Move into the next page. Shall I move? Molality. What and all the terms you learned today? Molarity, mole fraction, molality. Next one. Let us see the next one. Normality. Give the heading. Normality. Write that. Write the definition. One line you write. Normality. Number of gram equivalents of solute. Actually, in textbook, this normality won't be there. Okay, NCRT, don't use this term normality, but it will be helpful for you if you learn. So, normality, right? Number of gram, G-R-A-M, gram equivalency, spelling is here. Number of gram equivalents of solute dissolved in 1 liter of solution. Number of gram equivalents of solute dissolved in 1 liter of solution. So, write it. Formula you write. Number of equivalents or gram equivalents. Both are same. Number of equivalents or gram equivalents of solute divided by volume of solution in liter. Okay, fine. Now, if I say first 2 normal, what is the meaning? 2 gram equivalents of solute in 1 liter volume of solution. So 2 gram, don't worry what is this gram equivalent, I'll tell you. 2 gram equivalents of solute dissolved in 1 liter of solution. 1 liter of solution. Very good. See, molarity, normality, both are same to same formulas. Only difference is there we use only number of moles of solute. Equivalence place mole is there means that is molarity. Moles place equivalence is there means normality. That is only the difference. Both are same formulas. Okay, now listening everybody? Fine. Now let us see. Let us see. Normality means what? Normality means what? Number of equivalents divided by volume. See, molarity is what? Number of moles divided by volume. That's it. Both are same. This is equivalence. This is moles. That is the difference. Repeat everybody. This is equivalence. This is the moles. Now we will focus on equivalence. What is this equivalence? Number of equivalents means same like moles only. What is the moles formula? Weight by molecular weight. Molecular weight. Okay. This molecular weight we can say, or gram molecular weight we can say. Both are same. Molecular weight or gram molecular weight. Both are same. Now, equivalence means weight, same weight by gram equivalent weight. See here, gram molecular weight, here gram equivalent weight, that is the difference. Ma'am, then this is molecular weight, this is gram equivalent weight. So, what is the difference here is, I'll tell you again. See, gram equivalent weight and gram molecular weight both are same, but the difference is divided by valency factor. N is the difference. Again, I'm repeating. Again, I repeat. Don't worry. See, very easy. Very easy. Repeat this formula. Gram equivalent weight is equal to gram molecular weight divided by N. What do you mean by N? N is the valency factor. Valency factor. What is this valency factor is? For acids, we calculate in different way. For example, HCl is there. HCl. What is the valency factor? Number of replaceable H plus ions. What is the valency factor for acids? Number of replaceable H plus. How many H pluses we can replace? 1. So N is equal to 1. N is equal to 1 means HCl weight how to calculate is hydrogen 1 gram, chlorine is 35.5 gram. So total it is 36.6 gram. Okay, 36.5 no, 36.5 gram. Then what I want, don't worry, what I want to say is gram equivalent weight is equal to gram molecular weight. How much? This divided by its valency factor is 1, which means that for HCl gram equivalent weight and gram molecular weight both are same. So normality and molarity answers same we will get. Okay. But if for example, H2SO4, listen carefully. H2SO4 is present. See, H2SO4. How many replaceable hydrogens are present here? 2 replaceable hydrogens. So, valency factor is how much? 2. Then, gram equivalent weight is equal to gram molecular weight divided by valency factor is 2. So, gram molecular weight, I already told you for H2SO4, you wrote in your running notes today. 98 you wrote. So, 98 divided by 2 is how much? 2 4s are 8, 2 9s are 18, 49. 49 is the gram equivalent weight for H2SO4. So, same question. If normality, if they are asking, normality is equal to weight by gram equivalent weight into... Formula still we did not discuss, right? Formula still we did not. Okay. This understand how to calculate gram equivalent weight. Little more extra edge I will go. Little more extra edge. H3PO4, H3PO3 and H3PO2. H3PO4, H3PO3, H3PO2. How many replaceable hydrogens can you say in H3PO4? 3. H3PO3? 3. H3PO2? 3. But wrong answer. There is an exception here. So I will draw the structures and show you just for an idea. You no need to read anything other than your running notes. Most focus on running notes examples only. Okay. So see the structure. Phosphorus at the center and I'll put 5 bonds like this. This is a basic structure. Skeleton. Practice once this skeleton. 5 bonds, phosphorus will form. So 1, 2, 3, 4, 5. Why 5 bonds? What is the reason? I'll teach you. Coming classes, you learn in inorganic. Now, say this is a structure for H3PO4. This is a structure. This is a structure for H3PO. Same structure. But one oxygen I'll replace. I'll get this. Same structure. 2 oxygens I'll replace. See, here no oxygen, here no oxygen. Now, basicity means the number of replaceable hydrogens are which are connected with oxygens. See, which is connected with oxygen, that bond only we can break. This bond only we can break. This bond only we can break. So, N value is 3. Directly you can say by saying this. No need structure also. Here, number of replaceable hydrogens, how many? Which are connected with oxygen only, you have to count. So, 2. Number of replaceable hydrogens, how many here? Only 1. So, just have a look. Because by seeing this, you should not say for H3PO4 and H3PO3 and H3PO2 case, special cases. This is phosphoric acid, phosphorus acid, hypophosphorus acid. Names also not required. You will be learning. Okay. Now, basicity, how much? Basicity, the word basicity I am using means replaceable hydrogens. So, 3, 2, 1. Got it? Next one. For bases, I will use. See, bases. For bases, number of replaceable, write that. Number of replaceable OH minus ions. For bases. We call this as acidity. The name, what is the name, children? Can you tell me? Acidity. Now, I will give you a question. I want to test your knowledge now. Can you tell me what is the basicity now? How many OH molecules it can give? Come on, answer. How many OH minus ions it can give? Only one OH minus. So, basicity N value is only 1. Now, can you tell me CaOH twice? How many OH minuses it can give? Come on, faster. How many OH minuses it can give? Put in chat box your answer. How many OH minuses it can give? Very good. Super. 2 OH minus ions. So, N value is 2. Basicity concept is clear. This is a difference. Okay, very good. But if there is an ions, for ions, how you will calculate this valency factor for ions? Then for the charge, you have to consider charge on cation. What do you mean by cation? Ion with a positive charge is a cation. What do you mean by an ion? Ion with a negative charge is called as an anion. Listening. What do you mean by cation? Ion with a positive charge. What do you mean by anion? Ion with a negative charge. Let's say, for example, I am having Na plus. Can you tell me what is the valency factor here? +1. So, no need to say plus and minus, just 1. Ca2 plus. Can you tell me what is the valence factor? Say 2. Very good, because +2 is there 2. If I say PO4 minus 3, can you tell me what is the valence factor, children, now? No need to say signs, minus plus not needed. Just magnitude you take. 3. Okay, very good. SO4 minus 2. Can you tell me what is the valence factor? SO4 minus 2. Can you tell me the valence factor? Very good. 2 is the valence factor. You understand how to find it out. Very good. You learn for acids, you learn for bases, you learn for salts, because salt will break into ions and you will get it. This is for salts. I have to say it is for salts, because salt will, NaCl is there. NaCl, it breaks into Na plus Cl minus. So what is the valency factor? any ion you should take, either cation or anion, any one, because total charge on cation will be equal to total charge on anion. So any ion you can take. Very good. For example, if we have some ionic reaction, if you have, this is redox reaction, separate chapter is there in class 11th chemistry. There you learned what is redox reaction. You will learn, don't worry. Now you have to find valency factor. Now I will write one reaction here. Tell me what is the valence factor. Okay. Search plus. Don't worry how I am writing this reaction. No need now. You have to tell me what is the valence factor. For ionic reactions, N value is number of electrons change. Number of electrons change or transfer. Change or transfer. Can you tell me how many electrons are changing in this reaction? Can you see and say how many? 5 electrons change. So N value is 5. That's it. Okay. N value is 5. That's it. And there is one more formula also there. I will teach you later. That situation comes, that time I will guide you with that formula. Everybody clear regarding normality? Now let's focus on the formulas for normality. Capital N is normality. Capital N. So number of gram equivalents dissolved in V of liter solution. This is solution. So how can you write gram equivalents? Weight by gram equivalent weight into 1 by V in liter, which is equal to, how to write this gram equivalent weight? How can you find gram equivalent weight? Can you tell me? Gram equivalent weight is equal to gram molecular weight by valency factor. Gram molecular weight, how to calculate? You already learnt. Fine. Now, weight by gram equivalent weight. If it is in milliliter, what you should do? Divided by 1000 you should do. That 1000 goes top. These are the 3 formulas which you use. But which this topic is not in NCERT. Simply I have discussed with you because when we are doing some other questions, it may help you. Okay? Very good. Read the 3 formulas one more time. What do you mean by normality? Normality is equal to E by V, W by GW, gram equivalent weight into 1 by V in liter, W by gram equivalent weight into 1000 by V in milliliter. This is regarding normality. And one small formula I want to tell you. This formula also just put in your mind. Normality is equal to relation. Derivation is not needed. Small n into capital M, where n is a valency factor. This is the relation between normality and molality. What do you mean by, what is the relation between normality and molarity? Normality is equal to small n into capital M. What do you mean by small n? Small n, for acids, replaceable H plus. For bases, replaceable OH minus. For salts, that ion charge, either cation or anion. For ionic reactions, number of electrons change. That is the N value. Just if you multiply that small n with a capital M, you will get the normality. This is the relation between the both normality and molality. Very good. Now, put the heading. Weight by weight percentage. Come on. What is the formula? Weight by weight percentage. Weight by weight percentage. Write the definition. Weight of solute by volume of solution into 100. See, weight, denominator also weight, numerator also weight. Both weights only. Weight by weight percentage. Weight of solute by weight of solution into 100. You copied right. Now, I'll ask you one question. Tell me. If I say anywhere 10% weight by weight, what is the meaning? This meanings is most important because by hearting is not at all important. If you by heart it, you cannot understand anything. So by hearting, weight by weight percentage. So observe, weight by weight percentage means denominator is weight of solute, numerator is weight of solute, Denominator is weight of solution. So 10% means 10 grams of solute. What is that? 10 grams of solute. 10 grams of solute in total. How many grams of solution? Total percentage. Percentage means 100. 100 grams of solution. Everybody clear? Everybody clear? What is the meaning? Meaning is important. What is the meaning of 10% weight by weight? 10 gram of solute in 100 grams of solution. So, if you know solute, if you know solution, can you tell me solvent weight? Solute plus solvent is equal to solution. So solute is a 10, solution is 100, then difference is how much? 90 grams of solvent. So another meaning is 10 grams of solute dissolved in present in 90 grams of solvent, both together is 100 grams of solution. So solute by solvent is equal to solute plus solvent is equal to solution. Everybody clear? Understand? Very good. Now I'll give you, tell me, shall I erase this? Copied? Faster, faster. Right, come on, children, come on. Moving. Okay, I'm erasing this part. I'm erasing. Write faster. Erasing. Okay. Now write this one. Weight by volume percentage. Weight by volume percentage. When the question comes by seeing this term only, it should come in your mind. Okay, weight by volume percentage means. What is the meaning of weight by volume percentage? Weight of solute in numerator. Volume of solution. See, solution only I'm using. I'm not using anywhere solvent. Only molality case I used. Molality only I used solvent in denominator. All solutions only I'm using. Solution. Okay, solution. Weight by volume percentage is what? Weight of solute by volume of solution into 100. Weight of solute by volume of solution into 100. Very good. Very good. Okay. Now I'll give you one question. Tell me. 20% weight by volume means what is this? Tell me, yaar. Tell me. 20% weight by volume means what? How many grams of solute? Huh? How many grams of solute? Solute. I want information. Solute. How many grams? Tell me. Solute. 20 grams. Okay. Percentage is given means what is the meaning? Solution how much? Solution always 100. Solution is always 100, no change. Then solvent is how much? Solvent weight. Solvent 100 minus 20 is 80 grams. Everybody clear? So 20% weight by volume means weight of solute, weight is 20. Volume of solution is 100. I'm sorry. I should not use grams here. Why I should not use grams here? Volume is there. So I should use ml. 20 grams is dissolved in 100 ml of solution. So solvent and solution should be in same phase, right? That is only we have learned rule number 1. So that is 80 ml. Everybody clear? What is the meaning of 20% weight by volume? 20 grams of solute in 80 ml of solvent, which gives 100 ml of solution. Done? Very clear with these terms? Very good. Now, put the heading. Volume by volume percentage. Volume by volume percentage. Come on, everybody. Volume by volume percentage. What do you mean by volume percentage? Volume by volume percentage. Volume of solute by volume of solution into 100. Varkala Nagesh, are you writing? Writing? Okay. Volume of solute by volume of solution into 100. Very good. So, I'll give you one question. Tell me. 30% V by V. What is the meaning? Right. How much volume of solute, how much volume of solution, how much volume of solvent. These three information I want. 30%. What is the meaning of 30%? 30% means 30 ml of solute is dissolved in 100 ml of solution. That is the meaning. 100 ml of solution. 100 ml of solution. Very good. Now, solute is how much? 30. Solution is how much? 100 ml. Then solvent is how much? Solvent volume. Put in chat box. Volume of solvent how much? Volume of solvent. Most important is all in chemistry, clarity is most important. Clarity. That clarity, if you have, you will do it. You will do it. Why not? You do it. 70 ml. Very good. 70 ml. Super. Super. You are very clear. Very clear. Now, put the heading. Number of ppms, parts per million. Shall erase the screen? Erasing. Erase. ppm means parts per million. See this term, no, we will use for traces when the substance is in very small amount. Solute is very small amounts. Parts per million. Parts per million. Do you know our channel subscribers are 6 lakh 30 plus, means close to 1 million. 1 million. Please share, about our classes to friends so that we will reach 1 million subscribers. 1 million means how many? Now 6 lakhs we are. 6 lakh 31,000. 6 lakh 31,000 to 1 million means how many? 10 lakhs. 10 lakhs means how many zeros can you say? 10 rupees. 10, 100, 1,000 means 3 zeros. 10,000, 1 lakh, 10 lakhs. Correct? How many zeros are there? 10 power of 6. See, 10 power of 6 means 10 lakhs. 1 million. Parts per million. What is the meaning of parts per million? Out of 1 million parts, how many parts of solute is present? The mass of solute that is present in total mass of the solution, or the number of parts of the substance that is present in total parts of the solution is called as ppm, parts per million. See, this is like, this term we will use only for traces. Traces of solute is present, small quantities. Traces are like pollution. Of course, pollution is more nowadays. Traces of substance, traces of solute, traces, very small amount of solute is present. Then we use this ppm word. Everybody clear? Got the clarity? Very good. So if I say 2 ppm, 2 ppm, what is the meaning of 2 ppm? Can you tell me? 2 grams of solute dissolved in 10 to the power of 6 grams of solution. That is the meaning. What is the meaning of 2 ppm? 2 grams of solute dissolved in 10 to the power of 6 grams of solution. 10 to the power of 6 grams of solution. So if I ask you solvent weight, then you should say, ma'am, 10 power of 6 minus 2. So we cannot minus that. Out of 10 lakhs, if you remove that 2 number, it is very small number. So we can say 10 power of 6 only, solvent also. Okay, no need to subtract that. Very good, very good. You got the clear clarity. Super. Now, put the heading. Last term in concentration terms. Strength, last term, strength. What do you mean by strength? Strength of solution. This is the units. Units of gram per liter is the unit. Gram per liter. Strength of solution. If you see anywhere strength of solution, what do you mean by strength of solution? Mass of solute in volume of the solution. For example, if I say 5 grams per liter, if I say that, what is the meaning of 5? Very easy. See, the units you see carefully. 5 grams per liter means 5 grams of solute in 1 liter of the solution. 1 liter of the solution. Understand? Understand? What do you mean by 5 gram per liter? 5 grams of solute in 1 liter of solution. This unit is for strength. Strength. How much is the strength of the solution? Okay. Now I'll ask you one question. Tell me. 2 grams per liter is the strength. Can you write its form? Like this. Like how I wrote like this. Write on your own. 2 gram per liter. 2 gram per liter. Come on everybody. 2 gram per liter. 2 grams of solute in? Come on, tell me. 2 grams of solute in 1 liter of solution. Come on, write that. 2 grams of solute in, 2 grams of solute in 1 liter of solution. Are you able to follow? Are you able to write? Come on, 2 grams of solute in 1 liter of solution. Okay. You learned these many formulas, right? Now, I am going to give you one finishing touch question. This question connects all the things which you have learned till now. One question, just one question I am going to give you. This one question, let's solve all the types of numericals. Write everybody the question. 2 molar, 2 molar, 2 molar aqueous urea solution. Aqueous urea. Urea molar mass is 60. Molar mass of urea is 60 grams. 60 grams. You can write in brackets. 60 grams. Molar mass. 2 molar. Molar. Lar. Capital M. Molality. Not molality. Okay. If I use here small m, then it will be molality. Anything if they give also, you should be able to do. 2 molar aqueous urea solution has density at 1.2 gram per milliliter. Now they're asking find molality, they're asking find weight by weight percentage, they're asking find weight by volume percentage, they're asking find mole fraction, they're asking like this different things they were asking. Just one question. How to do? So today I'm going to teach you one box method, ultimate method. You all should solve the question based on this method only. Fix your mind. If you know any other method also, confine yourself to this method first. Because if you know this method, any sort of question easily you can do. Okay, one method for various numericals. Okay, na? What is this method is? First, identify the question. Okay. 2 molar. I told you. What is the meaning of 2 molar? What is the meaning? 2 molar means 2 moles of solute in 1 liter of solution. This is repeatedly you have to practice. How can you remember this? When you revise your running notes, it will fix in your mind. 2 molar. What is the meaning of 2 molar? 2 moles of solute in 1 liter of solution. If I say 5 molar, 5 moles of solute in 1 liter of solution. If I say 3 molar, 3 moles of solute in 1 liter of solution. So any question if they give, immediately you should write this point. Okay, very good. Next one. What you do is one box you have to make. Okay, we'll make one box now. Now we'll make 3 columns like this. Column number 1, column number 2, and top one horizontal row. Very good. What is the use of this? I am taking this just to mention. What I'm going to mention? I am going to take here number of moles of solute. This box is for solute. Solute information I am going to write here. Which information I am going to write here? Solute. Here I am going to write solvent information in this box. In this box, I'm going to write solute. Don't think that, ma'am, if I draw this box, my time will be wasted. No, practice time. If you do like this, automatically the speed will come. You will do faster. Okay, na? Solution. So now, according to the given question, 2 moles of solute is there. So about solute, you got which information? 2 moles. 2 moles you got. 2 moles. Do you know 1 mole of urea is how many grams? 60 grams. 1 mole of urea, 1 mole is how many grams? 60 grams. This is a fixed information. Urea formula is NH2CONH2. If you add all the weights, you get 60. It is a fixed information. You will be learning in coming classes. Don't worry. Urea 60, H2SO4 98, HCl 36.5, water 18, like this ammonia 17, like this few you will by seeing only you will find it. 1 mole 60 grams. See, 1 pen 60 rupees, then 2 pens how much? 1 pen 60, for example, 1 pen cost is 60 rupees. 2 pens you want to purchase. How much? Just a cross multiplication, no. So 120 grams is the weight. From moles, you calculated weight of what? Solute. Solute weight you got. Why, ma'am? Why you calculated solute weight? Simply I calculated. I want to find all the information from the given question. Okay, right. Next in the question, one more thing they have given. See carefully. Density. Density is given. Do you know the density formula? Density means that is for solution only. Okay, because urea solution has a density they were telling. Solution density is, density formula is, remember, mass by volume. Read everybody, what is the meaning of density? Mass by volume, mass by volume, mass by volume is a formula of density. Very good. Now what is the density? 1.2 grams. And what is the volume of solution we have? 1 liter. 1 liter means how many milliliters? 1000 milliliters is the volume which is given according to the given question. Solution volume. So mass we don't know. This is a 1000. This is a gram per ml. This is a ml. Then mass is equal to how much, students, tell me? 1.2 gram per ml into 1000 ml. If you do, ml will be cancelled. Then 1.2 into 1000 is 1200 grams is the mass of solution. So by using a just density and volume, so we know density here, we know volume here. Both are used and I calculated mass of the solution. Most important way to do the question. And you have to learn this box method for sure. Most important technique to solve the questions. One box is for solute, one box is for solvent, one box is for solution. All the given data first you have to write. Density. Density is equal to mass by volume. Density we know. Volume we know from by seeing this term. 2 molar means 2 moles in 1 liter. That 1 liter, that 1000 ml, 1.2 gram per ml substituted, mass I calculated. For which one? Solution. Now you know solution mass, you know solute mass. Can you calculate mass of solvent now? Mass of solvent. Tell me how much is the mass of solvent? What is the formula? Mass of solute plus mass of solvent is equal to mass of solution. What is that? Write everybody. Mass of solute plus mass of solvent is equal to mass of solvent is equal to mass of, read out loudly, mass of solution. So what terms we know? Mass of solute is how much? 120 grams. Why 120 grams? For 1 mole it is 60 grams, for 2 moles according to the given question. If in a given question 3 moles if it is there, 3 molar it is there, 3 into 60. If 5 molar, 5 into 60. If 1 molar, 1 into 60. Same method. Only digits will change. That's it. Okay, now 120 grams plus solvent mass we don't know. Solvent mass which is equal to solution is 1200 grams. Then solvent mass is equal to 1200 minus 120, how much? 1080 grams. 1080 grams is the mass of solvent. So three things we came to know. What are the three things? Solute, solvent and solution. Solute, solvent, solution. Okay. Now you should calculate molarity. Find it out, molarity. How to calculate molarity? Molality. I want molality. See, I don't have space here. I will take next page. Here I'll write molality side because I need this information. If I have this information, it's very easy for you to understand. What you do is continuation down you write. Don't write like me, down you write. Molality. Tell me the formula of molality, students. Molality. What is the formula of molality? W2 by, or one thing I'll write direct formula. What I will write, what I'll write is, okay, final formula only write. I'll write anything you can do. W2 by MT, out of three formulas, any formula you can take. 1000 by W in grams. Can I take this formula? Can I take this formula? Write neatly molality formula down because they're asking in a question molality. Part A, you cannot see here. It is they're asking molality question. So molality is equal to W2 by M2 into 1000 by W1 or directly number of moles. This is nothing but number of moles. You can put directly this place number of moles or weight. Weight is 120 grams. Molar mass is 60 for urea into, or directly number of moles given in question is 2. You can put a 2 in the question, into 1000 by weight of solvent is 1080. Weight of solvent. So to get this weight of solvent, only this much procedure. Otherwise, molality is equal to number of moles by weight of solvent in kg. No. Directly 2 moles we know. According to the given question, 2 molar means 2 moles. But weight of solvent we don't know na. That's why we did weight of, by using density we calculated solution weight. By using moles we calculated solute weight. Both we subtracted, we got a solvent weight. Only to get solvent weight, this much procedure we have to. Okay. Next, 0 0 cancel. 6 ones are 6 twos are. 2 into 1000 is 2000 divided by 1080. So see this calculation part. 0 0 I'll cancel. What is there? 200 divided by 108 is there. What we should do? No, we should not do 108 ones are 108. It will waste our time. Now see this. 200 divided by, let's say for example 100 is there. Then what it will be? 100 ones are 100 twos are, correct? No. But a denominator more than 100. So numerator answer will be slightly less than 2. Slightly less than 2. You got my approximation how I did. See, 200 divided by 108. So how you should do? Normal division also you can do, like a 108 here 200. 108 ones are 108. Again 92 is left. I'll put a point 0. 108 eights are, like this we can do. But that wastes our time. In options, if all options are very close only, we should do all this procedure. In exam, time won't be sufficient. Fatafat you should do, then only you can be able to. So see, 200 divided by 108 is more, very close to this. 100 ones are 100 twos are, but denominator is more. No, so answer is slightly less than 2. Then see the options which is less than 2, tick your answer. Clear everybody? Molality, how to find it out? Now second part number 2 is weight by weight percentage. See, what I'm doing is weight by weight percentage. Take weight by weight percentage. I cannot erase this weight. Weight by weight percentage. Come on. Weight by weight percentage. See the question. Weight by weight percentage. I need this entire information. You don't copy. Just you copy only weight by weight percentage. Only weight by weight percentage you write. Weight by weight percentage. I need this information. What do you mean by weight percentage formula? Say, Tell me the formula. Weight of solute by? Forgot, huh? Weight of solute by? Weight percentage. Weight of solute by? Weight of? You can see and say, no problem. Because today only I'm discussing, you can see and say. After class, you can practice. Weight of solute by? Weight of solution into 100. Very good. Now, see this data and tell me weight of solute how much? Can you tell me weight of solute how much? Already all the data you have, just a substitution only. Weight of solute how much? 120 grams. Weight of solution how much? How much weight of solution? 1200 grams into 100. 0, 0, 0, 0 cancel. 120 divided by 12. How much 12 ones are? 12 ones are 0. So how much is the percentage? 10% is the answer. So what is the weight by weight percentage answer? 10%. What is the formula? Weight of solute by weight of solution into 100. Very good. Very good. Next question. Next question. Tell me. Weight by volume percentage over. Over. Class over. Weight by volume percentage. Faster I need answer. Weight of solute is how much? Weight of solute. 120 grams. Volume of solution. Volume of solution how much? How much is the volume of solution? 1000 ml. Ma'am, how we come to know volume of solution? 2 molar given in the question. 2 molar means 2 moles of solute in 1 liter of solution. From that information we got volume of solution into 100. 0, 0, 0, 0 cancel. This 0 also cancel. 12% is the weight by volume of the solution. You don't copy this. Only that points you copy. This top calculation part you have to note it down. Okay? Very good. Very good. Now, mole fraction of urea. I want mole fraction of urea. How to find mole fraction of urea? What is the formula? Mole fraction is number of moles of urea by number of moles of urea plus water. Which and all substances are there? That substances only you have to take. Ma'am, how you came to know that is water? They did not say, right? If they didn't say about anything about solvent, we have to take water only. If they take any other thing like alcohol, glycerol, then only you should take that. If they did not say anything solution, only solution if they are telling, that is water only. Water molar mass is 18. Now number of moles of urea is how much? No need to calculate, directly given in question only. 2 molar means 2 moles. 3 molar, 3 moles. So directly you will get that solute moles from the molarity only. Very good. Next, number of moles of water, how to calculate? Weight by molecular weight is the formula. Weight is how much we got? Solvent 1080 divided by water molar mass H2O, no, oxygen 16, hydrogen 2, 18. When you are doing it will fix in mind 18. Then 1080 divided by 18. How much 1080 divided by 18 can you say? Can you say 1080? 1080 divided by 18. 18. So this is 2 9 sir. 2 table 2 5 sir. 2 540 sir. Okay. Next one is how much? 3 table can I take? 9 table 9 5 sir 45, 9 6 sir 54, 9 6 can I take 9 6 9 6 54. So 60, can I take 60 here? 1080 divided by 18 is 60. Super. Now number of moles of urea is 2 divided by 2 plus 60. Then it will be 2 by 62. It will be 1 by 31. That's it. You can stop here. 1 by 31 you can stop. They will give mole fraction in this respect only. 1 by 31 mostly. Okay. Very good. Everybody. Clear? Done? So today what and all you have learned? With this, our today's session is finished. Let's recollect all the formulas which you have learned one time. What you learned? What is a solute? What is a solvent? There are 2 rules which you have studied. What is the 2 rules? Solution and solvent should be in the same phase. Very good. Another rule is the substance which is in larger quantity. What is that? The substance which is in larger quantity is what? solution, solvent. The substance which is in smaller quantity is solute. Then what are the concentration terms you studied? Molarity, molality, normality, mole fraction, weight by weight percentage, weight by volume percentage, volume by volume percentage, number of ppms, strength. These are the terms you studied. Okay, after that what you have? One numerical we have seen with connecting all the things which you have learned. And in next session we will see interconversion terms. Okay, molality to molality, molality to normality. How can we do the interconversions? Today class is clear. Everybody, any doubt, any difficulty, you can raise your hand and you can clear your doubts. If any of you have your school or college, you can leave the session. Okay, remaining part you can attend. Or ma'am, this part I did not understand, means you can raise your hand and you can ask me question. Feel free to ask. Even if it is a small point also, I will explain you. I don't scold you. This is a small thing also, you can feel free to ask me. What about solid state, ma'am? Solid state not there, no? Syllabus got deleted, right? According to the new syllabus only. According to the new syllabus only. Ma'am, N factor for urea. We cannot say N factor for urea. We cannot, it won't dissociate. N factor is only for which will dissociate and gives the ions. Okay? Hmm. If in a reaction means change. Number of electrons change. Ma'am, for JE also deleted, no? Once you ask that, JE people also study this textbook only, no? NCRT textbook is the base foundation. So, you just ask the faculty, for advanced it will be there, I think. But for mains, once you check the faculty, it won't be. Ma'am, we cannot find normality for urea. You can find normality for urea. For anything you can find. But valency factor, if it comes, n value won't be there. One only you will put. Means no replaceable. Nothing. You don't put anything. Just gram molecular weight only you will place there. Okay. How is your first class? Are you able to understand? Nitya, able to understand the class? Hi, Nitya. Hello.
Hi, ma'am.
Hello, Nitya. Are you able to
Hi.
understand the class?
Yeah, yes, ma'am.
Will you revise today? Sure.
Yes, ma'am.
Where are you from?
Tamil Nadu,
Tamil Nadu, which place?
Tanjavur.
Tanjavur, near the temple only, na? Your house, that street. Correct, na?
Yes, ma'am.
Okay. Near grocery shop is there? That house only?
Yes, ma'am.
Good girl, good girl. What's a Nitya? Nitya. Okay. Mm-hmm. Shall leave you for today? Shall leave you? This is today's session. See you again in next session. Until that, keep smiling, keep shining. Have a nice day. Bye, love you. See you again in next class. Have a great day. The thing is, today two tasks you should do. Or doubt na? Please feel free to raise your hand. You can talk to me. No problem. Please talk to me. If you have any doubt, you just raise your hand. Raise your hand. Raise your hand. Ashish, Ashish, raise your hand. Ashish, where are you? Raise your hand. Raise your hand. Faster. If you delay, no evening bus students call me. Class will be delayed. Raise. If it is a raise. I cannot see you. Ashish, you have to on your camera. Have to on your camera. Ha, good boy. Come on. Tell me, Ashish. Hello.
Ma'am, if 1 mole of H2O and 10 moles of C2H5OH
Hmm.
plus 9 moles of any liquid or
Hmm.
any solvent, if
Hmm.
we take, then how we can find which is solute and which is
No,
solvent
see,
like that?
binary, it does not mean that only one solute, only one solvent only should be there. Okay. The substance which is in larger amount, that is always solvent, remaining are solutes.
Oh,
Clear? Mm.
okay.
Okay. Uh, Soundarya. Ma'am, why number of replaceable ions means acidity? You will learn, don't worry. Acidity means that OH minus ions are basic ions. No, that was replaced by only acid. That's why we will say acidity. Only acid can replace that OH minus. That's why we say acidity. Notes will share. Don't worry. No problem. We'll share. Please share. Send me the notes. Forward me the notes. Ashika? Ashika, na? Hello. Hi, Ashika.
Hi, ma'am.
Hi. Tell me, Ashika.
Can you explain how we should write 2 ppm? What does 2 ppm means? Can you explain that?
2 ppm means 2 moles of solute in 10 lakhs. I mean 10 to the power of 6 grams of solution.
10 to the power 6
6 grams of
grams.
solution. If suppose 5 ppm means 5 moles of solute in 10 to the power of 6 grams of solution. If 1 ppm means 1 gram of solute in 10 to the power of 6 grams of solution. That's it. Okay, Ashika.
Ma'am. While we were discussing weight by volume, that formula, you gave 20% weight by volume. You said 20 grams of solute in 100 ml of solution. But you also calculate the volume of the solvent, right, ma'am? Calculate.
Here, understand. See, ma'am, how can we subtract from volume that solid, that grams? That is your doubt, no? No problem. Actually, what we are doing is we are which is an solvent, solvent and solution should be in same state. That's it. Only based on that we have to write. We no need to do anything, any conversions, nothing. No need to do anything. That formula only represents that. 20% weight by volume only says that 20 grams of solute in 80 ml of solution solvent. Both together is 100 ml. It says that. Okay? No conversion is needed. Hmm. Okay. Thank you so much, all of you, for selecting me as your chemistry teacher. See you again in next class. Bye. Have a nice day.